Assalamu alaikum students. I'm a teacher from Ilm Academy. In today's lecture, I'm going to discuss about addition and subtraction of surds. As in the previous lecture, we have done some simplification with the surds. So this time we will be going on with adding and subtracting surds. So as far as we are concerned with addition and subtraction of the surds, we can only add or subtract the surds if we have the similar numbers inside the surds. Okay. Like, for example, if we have square root 5 and square root 5, so we can add them both and this will be 2 square root 5 if we will add them both, okay? But if we have two different surds, like two different numbers inside the square root, like one is square root 5 and one is square root 7, so we can't add them, we will just leave the surd like this, okay? The addition will not be going on after this, so we can leave it. So in this exercise, basically, our first concern for addition and subtraction of the surd will be this, that we will try to make the numbers inside the surd similar, and then we will simplify. So starting with exercise 1.8c, for the first question, what they gave, that give each answer in the exercise in the simplest form. So we are going on with the first part, and your part number A is, they gave us 2 square root 5, and in this we need to add 10 square root 5. Now you can carefully check that inside the square root we have similar numbers. It means that these are two similar surds. Similarly, if they give two similar surds, you can just simply add these numbers together. Like 2 plus 10. Let me show you in this. Along with this, we will be having this square root 5 only one time. So 10 plus 2 will be 12 square root 5. Okay. Like this step you can skip as well. You can directly write you like 12 square root 5, but I'm just showing you that how you will just going on with the surds addition. Okay, next is your part number B. In this they gave 8 square root 3 plus 2 square root 3 negative 6 square root 3. All the numbers inside this square root or inside the surd is basically 3. So you can easily add or subtract. So 8 plus 2, if I will add the first two numbers, this will be 10 square root 3 negative 6 square root 3. So 10 negative 6 will be 4 square root 3. And even you can do all the work like in one step as well, adding and then subtracting and directly getting the answer. So that will be also fine. Moving towards C part. In this C part, they gave us 10 square root 3 plus square root 75. Okay, so as we have square root 75, like along with this square root 3, so what we will be doing, first of all, basically we will just make 75 into factors so that we can have one number as 3, like 75 is basically divisible by 3. So we know that 25 3 times will be 75, and 25 is basically the square of 5. So what we can do is we can write this 25 as square of 5, and then we can make this 5 outside of this square root, and your number will be 5 square root 3. So now the simplification is done. We can add the surds together. 10 plus 5, it will be 15. Along with that, the square root 3 as it is. Okay, so 15 square root 3 is your answer for part number C. So sometimes if your numbers inside the square roots are not similar, then you need to make them similar. So some simplifications you can do. And these simplifications are similar to the previous exercise that we were doing. So if you want to check that how to simplify the surds, so you can check your the previous exercise for exercise 1.8b. So the D part they gave is square root 50 plus square root 18. So let's make the factors. So for this as well, we need to check the factors so that we can make them similar numbers inside the surds. Fine. So 50, if I will be checking, I can make it as 25 times 2, and 18 we can make as 9 times 2. Okay, why I'm choosing these factors? Because inside the surds we will be having then similar numbers. Okay, now 25 will be 5 square times 2, and this 9 will be 3 square times 2. Both you can just make outside 5 square root 2 and 3 square root 2, and after adding them to 8 plus 3 will be 8 square root 2. Okay, so this is your part number. Next, moving towards part number E. In part number E, we have square root 20, and we need to add square root 45 in this. Okay, now again we need to try the factors, like they will be similar in both of these two asserts, and one will be the prime factor and one will be the simple number. So accordingly, we can choose 5 4 times 20 here and 9 5 times 45 here. Okay. So now this time this 4 will be as 2 square, and this 9 we can make as 3 square. Okay, so 2 square and 3 square both are square. You can make them outside of the square root. And here as well 3 square root 5. So now similar surds we have, so we can directly add 3 and 2. This will be 5 square root 5. Okay. So in this way, when your surds will be having the similar number in sides, we can just directly add them together. Okay, next part number F. In F part, again, they gave us some of the surds in different numbers, so we need to make them inside the square root with similar prime number. One prime number you can choose for all of these. That will be similar in all of these. Fine, then we can just quickly go with them. So first of all, we have this 200. So we can go with 100 times 2. In this way, 100 will be the perfect square and 2 will be a simple number. Next, 18 we can have, so 9 times 2. And 72 as well can be divisible like 2, 3 times 6 and 2, 6 times 12 along with that times by 2. All of these numbers are having one prime factor as 2 and all the other numbers as squares. Okay, so we can make them all in the square of the number, like 100 is for 10 square times 2, and 3 square times 2, and this will be 6 square times 2. So now just make the numbers outside with the squares. We have 10 square root 2, 3 square root 2, 6 square root 2. So all these numbers are having the square roots 2 with them, so we can add and subtract the surds now easily. 10 negative 3 will be 7 square root 2, and adding this 6 square root 2 along with this, and 7 and 6 will be 13 square root 2. So this is your part number F. Hope so these are getting clear now. So next, moving towards part number G. In part number G, we have the surd as square root 12 plus 3 square root 48 and negative square root 75. So this time again, we will try to make one perfect square, and along with that one number will be the prime number. So 4 3 times 12, this will give us one perfect square, and one is prime number as 3. Okay, next, if I will check that, because I have taken one prime number here as 3, so I will try to make here as well a prime number 3. So I will just write this 48 as a multiple of 3 with some number. So we can just check it. So 3 1 times 3 and 3 6 times 18. So 16 3 times is 48. So 16 as well is a perfect square. Here as well, I will just make it with a factor with a 3 so that we can easily make the surd similar. So 3 2 times is basically 6 and 3 5 times is 15. Now all of these squares, we can just make them outside like 2 square root 3. Here this will be 3 and 4. Basically 16 is the square of 4. So you can make the 4 outside and inside just square root 3. And this is basically the square of 5. So like this. So simplify this a bit. 2 square root 3 plus 4 3 times will be 12 square root 3, and negative 5 3 times will be 5. Sorry, this is just 5 square root 3. So addition and subtraction, now we need to do 12 and 2 will be 14 square root 3, and from this we need to subtract 5 square root 3. So from 14, if I'm going to subtract 5, this will be 9 square root 3. So this one is your part number E. Sorry, the part number G, this one is. Next is your part number H. And in your part number H, they gave us again some surds with different numbers. So we will just make them with the similar prime factors. We have square root 80, negative 5 square root 45 plus 6 square root 20. Okay, so first of all, if I will make 80 as prime factor of any number, so for this I need to check that one must be a perfect square and one can be the simple number. So with 5 we can check it. Fine, with 5, if I will divide this 1 times is 5 and 5 6 times is 30. So it 16 5 times is basically 80. This will be 9 times 5. 9 5 times is 45. And this will be 5 4 times 20. So all of these now are having the perfect square. So 16 is the perfect square for 4. 4 square root 5. Now this is basically 9. This is having, so this is perfect square of 3 and square root 5. And this 4 we have, so perfect square of 2 and it's having square root and 5 inside. So this is 4 square root 5. 5 3 times 15 square root 5. And 6 2 times 12 square root 5. Now we can just add and subtract all the numbers together. So 4 plus 12 if I will be doing. So this will be 16. And 16 negative 15 will be just 1. 1 square root. So we have done the first complete part till part number H. Next, we need to go with part number 2. And in this part number 2, what they gave us, that we need to write this in the form a square root b, where a and b are integers. So integers, if we will be talking about the integers, basically these are the whole numbers, okay? Integers must be whole numbers. Either they can be positive, either they can be negative, okay? But they must be whole numbers. They can't be in the form of fraction. They can't be the form of decimal, okay? So for part number 2, we need to just simplify this one, and the simplification we will carry on just the way we were doing in the first one part. So this is really easy one. Again, we need to go with 44 square root 99. Both numbers are the multiples of 11, and 11 is a prime number. So we can go with 11 4 times here and 11 9 times here. So 4 and 9 are the perfect squares of 2 and 3. So 2 square root 11 and 3 square root 11 we can write for this. And if I will add 2 and 3, this will be 5 square root 11. Because inside the third, we were having the similar numbers, so we can easily add them. So here, basically, they're saying that in the form of a and a square root b, you need to write. So we have got the form. Here, a is basically represented by 5, and this 11 is being represented by b. So this is your part number 2. Next, in part number 3, we need to find the values of the k over here for part number 3. Question number 3, part number A. Let's work on. We have square root 27 plus 2 square root 75 equals to k square root 3. So if I will be making the factors for these number, 9 3 times is basically 27. And here as well, I will be making the factor with the 3. And from this as well, like from the right side as well, you can carefully check the hint that we need to make prime number like these number as a factor of a prime number. So the prime number that you will choose will be 3. So 3 times 25 will be 75. Okay. And here k square root 3 will be as it is. So 9 is a perfect square of 3. Make them outside. And here as well 5 is a perfect square. Along with that 2 was outside. So 5 times 2 and square root 3. So here k square root 3 we can keep as it is. So now simplify this. 3 square root 3 plus 5 2 times 10 square root 3. On the other hand, we have k square root 3. So 10 plus 3 will be 13 square root 3. And this will be k square root 3. So as we have the similar square roots, like similar surds on both sides, so directly you can compare that your k value is 30. So in this way, you can find out the value of the k for the other values as well, for the other parts as well. Like here again, we will just make them similar on both of the side, like the similar number inside the third, and then we can compare them easily. Fine. So moving towards the part B of question number 3, here they gave us square root k and plus square root 24, and this is basically equals to 12 square root 6. Fine. So as we need to find out the value of the k over here, so what we will do, we will try to make the similar surd inside the square root. So what we can do, square root k we need to keep right now as it is, and this we can make as 6 times 4. Okay, 6 4 times will be 24, and keep this in like similar. Now this 4 is basically the perfect square of 2, so we can just make it as 2 square root 6, and this will be 12 square root 6. So to make this one as similar to this number, basically inside we need to have the 6 here as well, so that we can add them both. But for making the similar number inside the k, what basically we need to do, this outside number as well, we will try to make it similar. Okay. So for making this one similar, we can just bring this number towards the other side so that we can add or subtract the surds, the similar surds together. Like this is positive 2 square root 6. Bringing that on the other side, this will be negative 2 square root 6. So both we can subtract easily now. 12 negative 2 will be 10 square root 6. Now to find out the value of k, we can just take the square on both of the sides like this so that we can have just k remaining with us, and this 10 square will be 100, and cancelling this square with the square root, we only left with 6. So 106 times will be 600. So this is your value for the k. Okay, so in this way, if your k, that the constant that they gave is inside the surd, so you can just take the square after just bringing the other one surds together. So you can just do in this way as well. So hope so these two parts are clear. So moving towards part number C of this question, we have C as square root 45 plus 2 square root k equals to 7 square root 5. Fine. So here again, like if I will make the 45 as the product of the prime factor and the one perfect square, I can make it as 9 times 5. And on the other side as well, they gave 5 inside the square root. This is 2 square root k and this is 7 square root 5. So we can make it as 3 square root 5, and this will be 2 square root k and this 7 square root 5 as it is. Now bring your similar surds together, like we have 7 square root 5, and bringing this 3 square root 5 on the other hand, this will be negative 3 square root 5. Okay, so 2 square root k, 7 negative 3 will be 4 square root 5. So this 2 as well you can bring on the other side, it will be 4 square root 5 by 2. Simplify this. 2 times is 4. So square root k is basically coming as 2 square root 5. So you can again take the square on both sides like this. Your value for the k will be 2 square as 4, and 5 will be outside of the square root. So 5 4 times will be 20. So this 20 is basically the value for the k for part number C. So hope so this is fine. Next is D1 part, and in this D part, what they gave is k square root 12 plus square root 75, and it's equals to 11 square root 3. So for simplification of this, again, like we can make this 12 as 4 times 3, this 75 as 3 times 25. On the other hand, we have this surd, so we will just keep that similar. So here, basically, this 4 is the square of 2. So instead of writing k first, you can write 2k square root 3. On the other hand, we can write 5 square root 3 and this 11 square root 3 as it is. So to simplify it further, we can just take this 5 square root 3 on the other hand. So this will be 11 square root 3 negative 5 square root 3. And this 2k square root 3 we can keep right now as it is. So first of all, this one 11 negative 5 we needs to do, as both of are having the similar surd. So this will be 6 square root 3. And when I'm just bringing this, the other two numbers that we don't want this with k. So when we will bring, it will be in the form of denominator like this. So 2 3 times is 6, and cancelling these square root 3's as well. So we only left with k is equals to 3. So this is your part number D. So here again, the concept for addition and subtraction of the surd is this, that inside the square root, you must have the similar prime number. When you have the similar prime number or any other similar number, you can easily add the surds together. But if you have some different numbers, so you can just make them into some factors so that you can have one perfect square, just the way I have 4 as perfect square, and one you can have a prime number. So in this way, perfect square you can make it outside, and prime factors, similar prime factors you can use to make the surd similar, and then you can go with addition and subtraction of the particular surd. So this is your part number D. Now moving towards part number 4 of this exercise. And for this, they are basically asking that find the parameter of this rectangle, and the rectangle they already gave us. And for this, you must know that if we will be talking about the rectangle, the opposite sides of the rectangle are exactly similar. If this is square root 90, this will be also square root 90, and this is square root 30, so this will be also square root 30. So just the thing is that the length and the breadth of this rectangle they gave us in the form of surds. So we need to find out the parameter of rectangle. So if we will be talking about the parameter of rectangle, that is basically 2 into length times width. Okay. This is the length, this is the width, because we have two similar lengths and width. So that's why I'm just multiplying with the 2 outside. So length we have is square root 490 centimeters, and width we have is square root 360 centimeters. So just we need to simplify them first. Again, we will just make similar numbers inside the surd so that we can have we can add them together. So 490 basically we can make it as 49 times 10. Okay, that can be like in this way. 49 can be the perfect square and 10 can be number that is not a perfect square. So 36 times 10, this we can go with. Now you can check 10, 10, we both have 10s inside the square root. So 49 is the square of 7 and this square root 10, and 36 is the square of 6 and this square root 10. Similar. So now we can add these two numbers 7 and 6. So 7 and 6 will be 13 square root 10. So multiplying 13 with this 2, so this will be 26 square root 10, and this will be in centimeter as well, because it's the parameter of the rectangle. So this will be also in centimeter. So it's your part number 4 for this exercise. So hope so this as well is fine. Now moving towards part number 5. So what they So in part number 5, they're saying that you need to show that this side is basically equals to 27. Okay, we have been given square root 12 plus square root 3 square equals to 27. Okay, for the solution of this, you can first take your left hand side and you can prove that equals to the right hand side. So for the left hand side, we have been given as square root 12 plus square root 3 square. So square root 12 I can make as 4 times 3, and this square root 3 similar, taking the square. Now this 4 is basically the square of 2, and inside you can write the square root 3 as it is, like this. Now both are similar, so we can add them, like this is 2 square root 3 and this is 1 square root 3. So in total this will be 3 square root 3, and taking the square as well. Okay. Now 3 square will be 9, and this square will cancel out the square root, only we left with 3. So 9 3 times is 27. That is basically equals to the right hand side. So this is the thing that they were asking to prove. We have proved this one. For the fifth one part, hope so this is as well is clear. Next, we need to move towards part number 6. So what they gave is that find the integer value of x plus y square, and they gave us the x and y value as well. Now for x and y, integer value means that you need to give your answer in the form of a whole number, and that can be either positive or either negative. There isn't any restriction for that. So x value they gave is square root 2, and the y they gave us square root 8, and take the square as well. Now 2 is already a prime number, but we can make this 8 as a product of a prime number and a simple square number. Okay, so we can go on with 4 times 2. So writing this square root 2, and this 4 is basically the square of 2. So you can write 2 square root 2 and taking the square as well. So both are basically the similar surds. If I will add, this will be 3 square root 2 and taking the square as well. 3 square is 9, and square root 2 square will be just 2, because square will cancel out the square root, and 9 2 times is 18. Okay, so your integer value for this x plus y whole square is 18. Okay, so this is for the part number 6. Hope so this as well is clear. Now moving towards part number 7, and in this again they are asking to simplify. So we need to just check for the simplification, and we will simplify until we will not having the further simplification possibility. So A part is 12 square root 7 plus 6 square root 7 by 3 square root 7. Okay. All of these are having square root 7, so your addition and subtraction is going to be very easy. We can just simply add the numbers together, 12 and 6. It will be 18 square root 7. Why? Because inside the surds, we have the similar number 7, 7. So we can easily add 12 and 6. So it will be 18 square root 7. Downward, we are having 3 square root 7. So 3 6 times is basically 18, and cancelling the square root 7s as well, we only left with the answer as 6. So this was really easy. Next, for the other parts, we need to first simplify for making the surds similar, and then we will add or subtract, okay? And the simplification, if you understood the previous question, so these simplifications will be really easy for you. So we have here 45, square root 45, we can make it as 9 times 5, and square root 20, we can make it as 4 times 5. Downward as well, we can make 80 into a factor like where we have 5. So 1 times 5, 5, 6 times is 30, along with that this 5. So next simplification I'm doing here. Basically 9 is the square of 3, along with that square root 5. 4 is the square of 2, so 2 square root 5. And downward we have 16, that is square of 4 and square root 5. So 3 negative 2 will be 1 square root 5, and downward we have 4 square root 5. So cancelling the square root 5, only we left with 1 by 4 as our answer for part number B. Okay, so this is the simplification that we have done for part number B. Next, moving towards part number C for this. In part number C, again, we need to simplify, but in the numerator and denominator, they gave us the surds. So we have square root 75 plus square root 27. In the denominator, we have square root 48 negative square root 12. Okay. So above we can make the factor for 3 because 27 as well is a factor for 3. We can just easily make it into. So 325 times is basically 75. Along with this 9 times is 27. So 1 is the perfect square and 1 is basically the prime number. Next for 48, again we will try to make it into a similar prime factor with 3. So 3 1 times is 3 and 3 6 times is 18, along with that 16 times 3. So you can check it through the calculator as well. I'm just making the factors directly like this. Now all of these numbers are having 1 perfect square, like 25 as the square of 5, 9 as the square of 3, 16 as the square of 4, and 4 as the square of 2. So just bring them out. 5 square root 3, 3 square root 3, 4 square root 3, and 2 square root 3. Now, as we have similar surd, we can add or subtract. Don't cancel them out like this. Just first add and subtract, then cancel them out. Okay, make them as a single number and then you can cancel them out. So 5 plus 3 will be 8 square root 3 and 4 negative 2 will be 2 square root 3. So square root 3 will be cancelled out, along with that this 2 4 times 8. So the answer for part C is 4. So this is your part number C simplification. Okay, next is your part number 8. And in this part number 8, what they're saying that they gave you this form and you need to give your answer in the form of square root C. C can be any number inside the surd that will represent C. So part number 8, we have square root 600 plus square root 24 by square root 288. Fine. So first of all, we can make 600 as 6 times 100, 24 as 6 times 4, and for 288, let me check if this as well is divisible by 6. So yes, this is. So if I will make 288 with a factor with a 6 as a divisible by 6, but it's giving me 48 as a number along with that with a factor. So for this, it will be better if we will take 2 because it's basically giving me 144. So this will be 10 square root 6 plus 2 square root 6. And this 144 is basically the square of 12. So 12 square root 2. So 10 plus 2 will be 12 square root 6. Downward as well, we have 12 square root 2. So cancelling these 12, we have only left with square root 6 and 2. So we can just make both of them in one square root. So 2, 3 times 6, only we left with square root c. Square root 3. So that is basically the similar form. It's in the form square root c that they were asking us to find out. So this is your part number 8. Hope so this exercise is clear. So using this exercise, you can just carefully work with the simplification and addition and subtraction of the surds. So this is for today's lecture. See you until the next lecture. Allah Hafiz.